Now we're going to talk about the absolute and conditional convergence. Okay, and if you hear a strange sound in the background, you may not be able to hear it, but my cat is sitting very close to us, and she is purring like crazy. So anyway, okay, so we have this theorem, and it says if the series of the absolute value of a sub n converges, then the series of a sub n without the absolute value also converges. This ought to make a lot of sense to you if you stop and think about it, because the series in the absolute value symbols means that all the terms will end up becoming positive. So if a sub n itself was an alternating series, then instead of having, a positive number and then you're subtracting a number and then you're adding a smaller number and subtracting another smaller number and all that, so you're doing this constant adding and taking some away, adding and taking some away. What we're going to have instead is just adding all of the terms together. And so this series is going to be larger than the series of just a sub n itself. And so if the larger series converges, then the smaller series will converge. And we saw that with our direct comparison test. And so this comes straight out of that idea. Okay, so we have the definition of absolute and conditional convergence. Number one, the series a sub n is absolutely convergent if the series a sub n converges and the series of the absolute value of a sub n converges. So if they both converge, then a sub n, the series of it, is absolutely convergent. It's going to converge no matter what. Case 2, though, is the case where we have the series of a sub n converging, but the absolute value actually diverges. The larger series diverges, but a sub n converges. Then this is conditionally convergent, and we'll see a case when that happens in just a second. So you want to just keep these two things in mind. Because of this case right here, sometimes it's a good idea for you to go ahead and actually check the absolute value first, because if it converges, you don't even need to go on with the regular alternating series test. If it's the absolute value, the series of the absolute value converges, then the series itself will converge when you're talking about your alternating series. Alright, so let's look at example number 1. Alright, determine if the series from 1 to infinity of negative 1 to the n over the square root of n converges or diverges. And if it converges, determine if it converges absolutely or conditionally. So let's start first by looking at the absolute value. So we have the series from 1 to infinity of the absolute value of negative 1 to the n over the square root of n. And that's just going to be the same thing as the series from 1 to infinity of that negative 1 to the n becomes just 1 over the square root of n. And the square root of n is n to the 1/2. So we have the series as n goes from 1 to infinity of 1 over n to the 1/2. And we know from all the work that we've been doing that this is a p series and p is less than 1, so this diverges because it's a divergent p series. Alright, now my cat's trying to climb in my lap. Alright, hold on. Okay, kitty. Alright, so we've got that to start with. So the absolute value, the series with the absolute value in it, actually diverges. So this doesn't tell me about the series that we were given itself, since this one diverges, because it's the larger series. So we are going to actually now have to go and test our original series to see if it converges, because if it does, then this would be a conditional convergence. Okay, so in our original series, a sub n is 1 over the square root of n, which is, like we saw, 1 over n to the 1/2. So the limit, since it's an alternating series, I'm going to go ahead and go through my alternating series test. The limit as n goes to infinity of 1 over n to the 1/2 is 0, so it meets the first condition. And a sub n plus 1 is going to be 1 over n plus 1 to the 1/2, which is in fact smaller than 1 over n to the 1/2, which is a sub n. So it meets the second criteria. So therefore, the sum of -1 to the n over the square root of n converges conditionally. And it converges by AST. I should have put that in there to begin with. Okay, and it's conditional because the series converges, but the absolute value, the series of the absolute value diverges. All right, example 2. Determine if the series from 1 to infinity of -1 to the n plus 1 over 2 to the n converges or diverges. And if it converges, determine if it converges absolutely or conditionally. So just like the last one. Okay, so again, I'm going to go to the absolute value one first. This is an alternating series, and so I'm going to go straight to this and see what it looks like. So the absolute value of a sub n is going to be the same thing as the series from 1 to infinity of 1 over 2 to the n, and that's the same thing as the series from 1 to infinity of 1/2 to the n, which is a geometric series. And it's a geometric series with r equal to 1/2, and so the absolute value of r is less than 1. And so this converges by our GST, our geometric series test. And so at this point, since it's an alternating series, and since the absolute value, the series of the absolute value of the a sub n converges, then we know, therefore, the series from 1 to infinity of -1 to the n plus 1 over 2 to the n converges absolutely. Okay. If you want to go ahead and show that the series of a sub n converges, then you could go ahead and go through the alternating series test. So the limit, let me define, a sub n is going to be, strip away the alternator, we get 1 over 2 to the n. So the limit as n goes to infinity of 1 over 2 to the n is 0. And a sub n plus 1 is 1 over 2 to the n plus 1, which is in fact less than 1 over 2 to the n. So that meets the second criteria, and so therefore the series of -1 to the n plus 1 over 2 to the n converges by AST, and then because the series of the absolute value converges, then it converges absolutely. Out of room. Absolutely. Okay, and that's, let me call my original one S sub n, and you can still do that. I haven't done that on these last couple videos, not for any particular reason, but you can do that. So, alright, so that's it. That's all there is to the absolute convergence or divergence. We've got our alternating series, and we just check the absolute value and see if it converges or diverges. If the original one converges, then you'll be able to determine your absolute or conditional convergence from that absolute value series.